We are starting chapter 2, and it's definitely a change of pace from what we did in chapter 1. Chapter 1, it was all about terms and postulates and how to write things in geometry. So 2.1 and 2.2, we're going to spend 2 days on each section and have a little quiz after because it's very different. It's logic. You can see a lot of this stuff on standardized tests and things like that, and those of you in forensics or debate, this is about how to make a logical statement. We're not going to dive way deep into logic, but this is just a little sampling of it. So we're starting with a conditional statement. A conditional statement is a logical statement with two parts. There's the hypothesis. Well, first of all, a conditional statement is if, then. If this, then that. And parents use this all the time. If you clean your room, then you can go out Friday night, right? And only if you clean your room can you go out Friday night. Well, the if part is called the hypothesis. The then part is called the conclusion. So on here, this is the hypothesis, then the conclusion. And a lot of times we simplify it and write it like that. And you could say if P then Q, or we often, when it's written that way, say P implies Q. So if you have P, then Q. All right, so identify the hypothesis conclusion, then write it in if-then form. So all birds have feathers. So bird is like our hypothesis, and feathers is our conclusion. If it's a bird, then it has feathers, right? So, but we want to speak in nice English sentences. So we'll say if an animal is a bird, then it has feathers. Okay, this one, it's a little tricky. Where's the hypothesis here? Well, notice, see that if, that indicates that this is the hypothesis, and then this here will be our conclusion. So we're going to write it in that if-then form. If you are in Houston, then you are in Texas. Now, negation is when we want to say the opposite of the original statement. So, for example, you are in Houston. Well, the opposite of that would be you are not in Houston. So the negation is the opposite. Usually we use words like not. Now the notation, the symbols for it, the symbol for negation is that squiggle. And when we write it, like that means not P. So that means tell me the opposite of P. So that is how we symbolize the negation. So write the negation of each statement. So if this was P, right, if this was our P, then not P, the opposite of that would be the ball is not red. Okay, pretty straightforward. Now, if this is P, right, if this is our P, what would be the opposite of this? Well, the opposite of the cat is not black would be the cat is black. All right, so let's try. Here's some for you to try. So if you're watching the video, pause it, do it, then push play so we can you can do it together. Okay, so all angles are acute angles. If you have a 30-degree angle, then it's an acute angle. So let's put that number one. If an angle, remember we always want to use good English, is 30 degrees, then it is an acute angle. Number two. Okay, so because is sort of like an if, isn't it? Because this, then blah, blah, blah. So that's sort of like an if. So this is our hypothesis, this is our conclusion. So some of those that have the if or the because later in the sentence, be aware of that. So this would be if x equals -3, then 2x plus 7 equals 1. For these, now we want to write the negation. The shirt is green. The negation would be, so not P, we'll just remind ourselves, the shirt is not green. Like I wrote it in sort of a green color. And number 4, if this is our P, right, not P, the opposite would be the shoes are red. Now, related conditionals. We're just going to look at one today. We're going to look at 2 more tomorrow. So we have our conditional statement. This is our conditional statement. If P, then Q. Now, another form of the conditional statement or a related conditional is the converse. So notice the converse, here's the converse, and it's if Q, then P. Notice we're flip-flopping our hypothesis and conclusion. We didn't talk about truth values yet, but I think everything we wrote so far, like these 2 conditional statements, if an angle is 30 degrees, then it's an acute angle. If x equals -3, then 2x plus 7 equals 1. So all those are true, but when you flip-flop the hypothesis and conclusion, it's not always true. So just be aware of that. So let's go back here. Okay, write the conditional. Okay, so let P, this is our P, this is our Q. So let's take a look at that. So the conditional would be if you are a guitar player, then you are a musician. Okay, so a musician we would define as someone who knows how to play an instrument. So that's true. So I would say that's true. If you play the guitar, then you could be called a musician. Now the converse, we are going to flip that, right? So we would say if you are a musician, then you are a guitar player. Well, is that necessarily true? No. A musician could play the violin or the clarinet or the piano or play something else. So just because you're a musician doesn't mean you're a guitar player. So we call that false. And if you say something's false, you have to give an example of why it's false. We call that a counterexample. Counterexample. So you don't need to go in a big description. You can just say false, and then you could say piano player or something like that, or piano. So if you say something's false, provide a counterexample to say why it's false. Now, I'm just looking at where we're going here. Biconditional. A biconditional statement is when the conditional and the converse are both true. So like I said, very often the conditional and the converse are not true. You see them true when it's a definition, and you'll see in a minute with the example. So definitions are biconditional statements. Some other things could be, but definitely conditional. So if P then Q is true, and if Q then P is true, then we can write this like P, and we say if and only if Q. So that will always be true. And the double arrow means you can go one way or the reverse, and it's both true. So we say that that symbol there is if and only if, is how we would read that, and that's it in symbols. So P, if and only if Q. Okay, so, and we can use those if and only if. Now let me show you a shortcut. So if and only if, we can abbreviate as IFF. So you can use that. And we, It will save us a few words there. If and only if. Okay, so rewrite the definition of perpendicular lines as a biconditional statement. So two lines intersect to form right angle, then they are perpendicular lines. So it's telling us to write the biconditional. But let's just look at the converse. So if two lines are perpendicular, then they intersect to form a right angle. See how that's also true? So we would say two, I should probably not, I shouldn't use a number to start a sentence. Proper English. Two lines intersect to form a right angle if and only if they are perpendicular lines. And that's how we would write that biconditional. All right, so we've got some things to try here. So number 10, it says, if an angle is a right angle, then its measure is 90 degrees. We can see the converse would be if an angle measures 90 degrees, then it's a right angle. So that could be a biconditional. And so you would say an angle, and you could pause this and try these on your own and then push play, is a right angle if and only if its measure is 90 degrees. You can see for this assignment, you might be using your keyboard more than your pencil. Number 11, if two line segments have the same length, then they are congruent segments. If two segments are congruent, then they have the same length. So we can see that. So we could say two line segments have the same length if and only if they are congruent. All right. So what they're giving us in 12 and 13 is they're giving us the conditional and the converse, and they want us to rewrite it as a biconditional. So we see if Mary's taking theater class, then she'll be in the fall play. If Mary's in the fall play, she must be taking theater class. And so we could say Mary is taking theater class if and only if she is in the fall play. And finally, 13, if you can run for president, then you're at least 35 years old. And if you're at least 35 years old, then you can run for president. And so we would say you can run for president if and only if you are at least 35 years old. All right, so like I said, you might be using your keyboard more today. It's a lot of words instead of writing, and that gives you the foundation for conditional statements.